This is the video guidance for the worksheet called Spheres. The essential question is, how do I find the volume of a sphere? How do I find the volume of a sphere? Alright, let's see if we can get through this reasonably quick. The review, find the volume of a triangular prism. Please make sure you are following the directions. Make yourself shade the base and circle the height. I've had a number of you not watching your videos, just blindly going through these worksheets, and I'll tell you, I'm having a lot of those students, those maybe about 10 students, they go, oh, the height is always measured from the ground up. Most of you are wiser than that and better students because you are watching your videos and you are understanding height is the distance between the two bases, and for a triangular prism, the base is always a triangle. It doesn't have to be on the bottom to be the base. Here is looks like a rectangular based pyramid. Remember, your volume here has 1/3 in it, right? Your formulas class. Please get in that good math habit. Here is a cylinder. Be careful. You need to find the radius of this before you can find the base area. You've done this before. Here is a shape with another shape cut out of it. Remember, we are cutting the middle out of this cylinder. That means you are subtracting. We are not adding these two volumes together. We are subtracting the smaller one from the bigger one. Alright, that covers the first column. That was easy. Second column, here's my example. How do you find the volume of a sphere? Well, we don't have a base for a sphere, so all we need to do is identify the radius. In this case, it is 8 centimeters. And then our volume is 4/3 times pi times radius cubed. Number one mistake that I will see on the test is you're going to write radius squared if you're not engaging all of those brain cells, because if you get used to radius squared in other formulas like the base, like the area of a circle, you're going to write a 2 here. This is radius cubed. Remember some of the guidance I've given you before? I would say get yourself in the habit of putting this in parentheses. Let me change that color. Putting this in parentheses, because when you put this in your calculator, if you put that fraction in parentheses, you can do this all at one time. So here we go. Volume is 4/3 times pi times radius cubed. And now the question is, how do I put a cube in my calculator? So let's bring up the calculator that you have access to from the website. Let me see if I can move this over to the other side. There we go. Alright, class. Now on this calculator, you'll see there's actually a button that allows you to raise something to the 3rd power. There's your square. There is your cube. But notice there's also a key here that lets you raise a number to any power. So if I put this key in, just going to show you something. If I put 2 in here, and then I press this key, notice it puts the little hat, or a caret we call it, right here. That mathematically means the next number you're going to put in is your exponent. So 2 raised to the 3rd power, that's 2 times 2 times 2. You better be getting 8 there. But that key is so flexible. If I want to raise the number 8 to the 5th power, I would use this key. If I put a 5, that's 8 raised to the 5th power. That's 8 times 8 times 8 times 8 times 8. So use either of these keys. If you want to use the one that has a cube, that's fine. But get used to this key, because the calculators that we have in our class, if we ever get back to class someday, are going to have a key like this where you can put in any exponent you want. So here's how we're going to put in this equation. Parenthesis, 4 divided by 3. There's my 4/3. Then I'm going to put my pi symbol. And you can put it in parentheses if you want to. Doesn't make any difference. And then I'm going to put parentheses, and I will put 8. And then I'm going to hit my cubed. So there it is. 4/3 times pi times 8 cubed And there is your estimated volume, 2144.6. And because the next number is a 6, I'm going to round it to 0.7. So 2144.7. And then don't forget, this is going to be in centimeters cubed. All right, let's continue. So if I look at number 6, you can see that the radius kind of looks a little bit strange. I'm trying to scroll right now and I can't. There we go. Doesn't matter which way the radius goes. It go up, down, left, right, a little bit to the left, a little bit to the right. As long as it's the distance between the center of the sphere and a point on the surface of the sphere, it is the radius. Take a look at number 7. Be careful on this one now. This one's a little bit confusing, but 2.6 meters is not the radius because it's right below the center. That means 2.6 meters is the diameter of this sphere. You know what to do to change that to radius. Question number 8. The great circle of the sphere below has a circumference of 18 pi meters. What is the volume of the sphere? And then take a look. So we don't know what the radius is yet, but we're going to have to find the radius before we can find the volume, because the volume of a sphere just needs the radius. Now class, if you look at this, I want you to picture this. This middle right here, this center, or it's called the hemisphere or great circle, it divides the sphere in exactly 2 halves. If you just picture that, if you slice that out, that's just a flat 2-dimensional circle. And if we know the circumference of that circle is 18 pi, then we can easily find the radius, because I'm teaching you always write your formula. So I know that circumference is 2 pi r. Well, the circumference of this circle is 18 pi. Now look, just like always, if I can get an equation with only one variable, there's our one variable r, then I know that I can solve this. I can solve for this variable. I'm not going to do this, but divide both sides by 2 pi, and you'll be able to cancel the pi value because it'll be on the top and the bottom of the left side. It will cancel on the right side, and you'll figure out the radius is actually equal to 18 divided by 2, which is 9. So once you find your radius of 9, you can easily now find the volume, because now you know what the radius is. Alright, so that's a 2-step process. Figure out the radius first. Why did we learn the formula for the circumference of a circle? Well, here's a place where that's going to be applicable. In fact, class, if I gave you a baseball or a softball or a basketball and I asked you to find the radius, one of the easiest ways to find the radius is to take a string and go exactly as close as you can right around the middle of that ball, whatever type of ball it is, and then take that string now, figure out when it touches itself, pull it out straight and measure it. That'll give you the circumference, and then you can use the circumference formula to actually find the radius of that particular ball. All right. An NBA basketball has a great circle circumference of 9.5 pi. All right, you just did that for question number 8. You can complete that for question number 9. Now, I got to let you know, please do not take shortcuts on this. I've got students who will take shortcuts on this. They'll go, oh, I can figure out the radius directly from here without doing any calculations. Trust me, class, that only appears to work because this great circle has a pi value in it. If I told you this radius was 189 millimeters, you have got to do the math. Don't do a shortcut, please. Use the circumference formula to calculate the radius of the sphere and then find the volume. No shortcuts here. I want to make sure you guys are getting your accurate answers. All right, question number 10. Class, we've covered composite shapes before. I want you to see this ice cream cone right here is just a cone, and I know the radius of the base and I know the height, so I can figure out the volume of my cone. Remember, it's 1/3 base area times height, and I can actually figure out the area of this shape right here Because that's a hemisphere. It's half of a circle. So when you half of a sphere. So when you find the volume of the sphere, 4/3 pi r cubed, when you get that volume of the sphere, I need you to divide it by 2. So the volume is going to be divided by 2, and that will give you half of your sphere or your hemisphere. And then clearly we're not subtracting or removing anything from this shape. We're going to add the cone volume to the half of the sphere volume, and that will give you the volume of the entire shape. Alright, now this one's a little bit confusing, so I'll cover number 11 and we'll see if you can do 12. What is the volume of the largest sphere that can be cut out of this block of wood shown below? So you're given a block of wood. It looks like a cylinder. It's got a 6-inch diameter and an 8-inch height, and the question is, what is the biggest sphere? I'm going to go ahead and just draw a sphere in here, show you guys what this looks like. So what is the largest sphere that can be cut out of this block of wood? And the answer is the largest sphere is going to be limited by the smallest dimension. So if you look at these two dimensions, the height is 8 inches, the diameter is 6 inches. This is the smallest dimension. It's kind of like when you pack an Amazon box, nothing's going to fit in a box that's smaller than the object that you want to put in it. And what's limiting the object you put in it is the smallest dimension of the box. So find the smallest dimension, and that is the largest diameter of your sphere. So the diameter, the largest sphere you can fit in here is going to have a diameter of 6 inches. Change that to radius, and then figure out the volume of that sphere. 4/3 pi radius cubed. When you get down to number 12, notice class, don't get your brain stuck on the fact that it's always the top dimension or the base dimension. Look at this one. Figure out which of these is the smallest. The smallest number is going to be the largest diameter of the sphere that fits in here. So pick your smallest number. That's going to be your diameter, convert it to radius, and then find the volume of the sphere. That will be the largest sphere that will fit inside of this particular cylinder. Alright, hope that helps you. Take a look at review. What is the vertex of this? Well, class, what form is this? Standard, vertex, or intercept form? Whichever form this is, you know how to find your vertex. It's in your quadratic equations flipbook or in your quadratic equations notes. What is the vertex of this? Well, is it standard form, vertex form, or intercept form? If it's standard form, you know to use negative b over 2a to help you find the vertex. If it's vertex form, you know to use h and k to find the vertex. If it's intercept form, you know to take your two intercepts, the two x values that make the equation equal to 0, add them together and divide by 2. There's your beginning strategy to find the vertex of intercept form. And then last one, number 15, factor this. I love it because this has an a value equal to 1. It's pretty easy to factor. Number 16, solve this by completing the square. Now I want you to notice these are the exact same equation. So when you factor and get your final solutions, I'm assuming there are 2 of them here, then when you solve this by completing the square, if you're successful, you'll get the exact same 2 solutions. Okay, again, like anything else, class, if you need help on any of these look-backs to quadratic equations, please text me and remind and tell me which number you're struggling with, and I will give you guidance, or if necessary, we'll get in a Zoom session together and go over these. These are the skills you have got to keep fresh in your mind because you will begin to use them immediately in Integrated Math 3 next year. All right, so we got those done. Exit question. Sorry, it doesn't say exit question, but this is your exit question, and you should be good to go. And I just realized on this worksheet, I don't have the answers to number 12 and 16. I'm missing some answers. I'll make sure on the worksheet that I post in your assignment, all the answers will be there for you to be able to check your work. And do not hesitate to ask me questions. That is what I am here for. All right, class. Hope this has been informative and helpful for you. Do well on this worksheet. Hope you have a good day. Bye-bye.